Greetings, the Astro 30 here yet again with a short one for you. I say that now, but it usually doesn't turn out that way. Anyhow, assume we've got a battery powered device. Now, we also want to run it on a DC plug pack like that. And unfortunately, the electronic device may not even have a DC jack on it. But it is possible to add one. Or you could use this for your own creations and just want to know, how can I have a battery supply as well as a DC supply from a wall wart, for instance. And how can we have both of them connected at the same time? Because if you're lazy like me, you may forget that there's even a battery in the device and just run it off the DC plug pack all the time. Well, I'll show you. The average person might just oversimplify things and just think, oh, well, we can just do this. Here's our DC socket, and we'll just connect that directly across our battery. No. Don't ever do that. Because now you're forcing a lot of current into this battery, and if this battery is an alkaline type battery, they're not rechargeable. Also, this is not the correct way to set up a battery charging arrangement if you want the DC supply to also recharge the battery or maintain the battery. There's a special way of doing that, and that is not the way. The more elegant way is to use this sort of DC supply splitter arrangement where it features two diodes. Now, the way this works is, this is basically an OR circuit, like a logic gate OR circuit. That is, either input can be true for the output to be true. If no input is true, then there's no output. Usually, the DC supply plug pack will have a slightly higher potential in it than the original battery. Usually. So, in this arrangement, the DC plug pack will win and current will be drawn through this diode and nothing drawn this way. Theoretically. In the real world, there may be a few microamps being drawn through this diode. Say for instance the DC plug pack was unplugged, now current will flow through this diode into the device to maintain it. It's the same as if you had a power outage, and this is basically a backup battery. Or this could just be easily a mains transformer supply here with a full bridge rectifier and this diode here as well. And most of the current will come off the mains transformer, leaving the battery there in case the power fails. Now, speaking of batteries, if you wanted to maintain this battery, the more elegant solution is to add in a fixed resistor as a current limiter to there. Okay? And whilst this plug pack is plugged in, it'll force some charge back into the battery. Trickle charging it is the correct way to do it, and there's a special formula for calculating what resistance value this needs to be for the type of battery you're using, but we won't get into that here because it's not relevant to the conversation. But that's one way of doing it. You could also use a voltage regulator arrangement to charge the battery as well. However, we're going to just stick to this. So I'm going to do a practical demonstration of this. And a short time later I've got two 1N4004s there. They're joined here at this point, so that's going to be our output node, and they're just separated apart here so I can connect the devices individually, like the battery and the supply. And this wire sticking up is just a convenient place to put all the ground leads. I'm using that multimeter today as a measuring tool. Got my 9-volt battery hooked up ready to connect. Buried over there in the background is a DC power supply. Now I'll need to talk about the DC power supply in just a little bit, but for now I'm going to hook up my battery. I'm going to use the lower diode here because it's convenient. And if we look at the meter, once it finishes carrying on, it looks like we're getting 9.4 odd volt out. The battery was only measuring 8.2 yesterday, but okay, whatever. But it is falling. So now, if we hook up the DC supply to the other diode, it's more like 10 volt. So that's actually putting out a little bit more than 9 volt, unless that meter's accuracy is off, which it could very well be. Anyhow, we can see that the DC supply is now a higher potential than the battery, so there should be no current draw off that battery. However, remember, using this arrangement of two diodes, you're going to experience a 0.6 of a volt drop across that diode, so keep that in mind. If we now disconnect this DC supply, we drop back down to the battery voltage. If I disconnect the battery, obviously we all know what's going to happen. It dies in the arse. So I'll connect the battery back up, and I will connect up the DC supply. Now I'll disconnect the battery. No change. Okay, and I know you guys will never forgive me if I don't do a real world current draw test. So currently I've got the battery hooked up to the circuit. I've got an red LED, which looks kind of weird on the camera, but it is indeed red. It is indeed glowing. Going through a 2.2k resistor off of the node here at the junction of the two diodes. I've got a 220 ohm resistor in series with the battery connection to the diode, and I've got a multimeter measuring the voltage drop across said diode. And now if we use ohms, yes, okay, I know that's getting a little old, we can calculate that that is a current draw of roughly 1 mA, maybe 2 at the best. Okay, so if we hook up the main supply to the other diode now, see, the voltage drop across that resistor falls to 0, meaning we're getting absolutely no current draw, which is the whole entire point of the circuit. Isn't that wonderful? I need to talk about DC plug packs. Now, this is known as the barrel, and this is known as the tip, the center bit. A lot of the time it's positive tip or positive center and negative barrel. Sometimes that's not the case. You need to check the polarity first before plugging this into anything, because there's nothing worse than connecting this up to something backwards and blowing it sky high. However, with those diodes there in that circuit, that also prevents the polarity being incorrect. So that's another handy feature of using those two diodes. Now, one final thing I want to touch on before we go is there are DC jacks available where it has a switch on the barrel side of it. This would be representing the barrel. Now, this is normally closed when there's no plug inserted in the socket. So you could use this method as well by connecting the negative of the battery to the center of the switch, so that when the plug's unplugged, it has a path to ground of the circuit. And when the plug's plugged in, it disconnects the battery and then allows the DC voltage to go through to power the circuit and still ground there. And your positive is formed there. However, this will limit you now that you can't charge the battery. However, if you're using this for your own home electronics, the likelihood of you having a rechargeable battery anyway is probably next to 0. However, one final thing about these plug packs, wall warts, whatever the hell you want to call these things, most of them these days are switch mode power supplies, and they can be inherently noisy, and you may experience a little bit of mains hum on an output, especially in sensitive audio equipment. So the way you could fix that is to simply put in a filter capacitor on your output, so you're removing some of that DC hum. Alright, and that's it for this one. Thank you for watching, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook, and you can always become a Patreon member for as little as $1 a month. I would like some more Patreons, please. Anyway, this is Yastro30 saying, hope you have a great day, and see you in the next one.